I'm going to pass it off to Christine Szymanski, the Stream Quality Monitor Coordinator with the Division of Natural Areas and Preserves with the Ohio Department of Natural Resources. Christine, how are you?
Hi, good. And that was a really good pronunciation. Congratulations.
Thank you. I've been working on it.
All right. Hi, everybody. Thanks for joining. It's really cold and snowy outside, so it seems like a good time to talk about the rivers and think about the summer. So I'm going to share my screen here. I'm going to take you through the Scenic River Program for Ohio and kind of tell you what that's all about. And then talk about what sort of animals we look for in the stream that will help us determine water quality. So a little bit background of me. I've been with the division for about 4 years, a few months shy of a few years here, 4 years. And I started as an intern. Before that, I was a volunteer. And I was working toward my graduate studies in natural areas watershed management, so environment and natural resources with Ohio State University. And then coming into the division, we do a lot of education with the public. So here we're at a COSI event talking about the animals you can find in the river and what that tells you about water quality. And we take people out on canoe trips and kayak trips too, so they can experience their natural resource. And then again, we do a lot of school programming. So these are workshops we normally would be holding in the summer. And this past summer, because of COVID, we passed on all of that for safety. But this coming spring and summer, we're hoping to be able to do that again. So if any of this sounds interesting to you, I'd hope that you'll join us for a workshop and maybe one at Paradise too this coming summer. So the Scenic River Program, if I'd say a river is scenic, what are some things that people would think that means? Like, what does scenic river mean to you? And you can chime in audio or through the chat, either way.
I'm thinking about something that's very picturesque, maybe lots of green around, maybe a corridor lined with trees.
Yeah, so I picked this picture from one of our current volunteers because it sort of describes that. You know, it's a very beautiful, picturesque area, trees, clear water. So there's definitely like an adjective form of saying scenic river. But it's also goes a little bit deeper than that for the state of Ohio. So you guys see the pictures here on the right side of your screen. Does anyone know what that is, what that's depicting? It's one of these like sort of famous environmental things that happened in Ohio.
Cuyahoga River.
Cuyahoga River. Yeah, so it's caught on fire multiple times in the double digits. And then obviously that's not the water. So there's chemicals and pollutants in the river. People used to use rivers as sort of open drain pipes, just putting their waste in it. Down here in central Ohio, the Scioto River had miles and miles where they couldn't find anything living in it. And so this was commonplace in the United States. And in the 60s, as this was happening, it kind of became a picture, like something to look to for the environmental movement. People were like, this is not what we want to have happening. In the 70s then, with that environmental movement, you got the Clean Water Act, you got the EPA, you have the National Environmental Policy Act. But before all of that, we had the Scenic River Act of 1968 here in Ohio. So with that Cuyahoga River issue, we also had people down in Southwest Ohio by the Little Miami who are noticing similar things, just lots of pollutants. They were concerned about this really pristine natural area degrading, an area they wanted to swim in, somewhere they wanted to fish. They wanted that to still be able to recreate with and just to keep it in a healthy condition. And so because of that just community involvement and movement, we ended up with the Scenic River Act, and we now have 15 rivers in Ohio that are designated. And we'll go into that a little more detail here. So if you're choosing what river in Ohio to be designated, what's special about them? So to start, we look at water quality. So obviously we don't want them catching on fire. And so that's going to be, how much dissolved oxygen is in the river. If you have low oxygen, that's actually considered a pollutant. We need the oxygen for our animals to live, our bugs and our fish. And so don't want heavy metals and other pollutants like that in the river. And then we also need an intact and functioning riparian area. It's kind of a big word. So riparian just means that it's an area next to the river. And so when we say we want a functioning riparian area, what do you think that means? What's a healthy, good-looking area next to a river? What does it look like? If you go to the parks and you're walking along the river, what does it look like?
Forest or prairie.
Mm-hmm. So some nice native vegetation. So our riparian areas that we look for are going to be thick, like over 100 feet depth of natural area. So as they were saying, it could be prairies or it could be trees and forests. What are some things that forests might do and prairies if they're along the side of a river? Does anybody know before I go into it? Or any thoughts?
They clean, cool, and slow down the water coming into the river.
Yeah. So normally we're doing this program, we're out standing, in the river or by the river, and we're standing under these trees. And I'm like, go step that way and you're in the sun, or we step this way. So there's such a dramatic difference just from the shade of those trees. And so why that is important is the coolness. So the cooler water holds oxygen better. So that's going to help protect that habitat. Some of the other things that were mentioned too were water infiltration. So that's what he meant by slowing the water. So one of the things that happen to our rivers, especially in urban areas, is that the water gets to those areas too quickly. So in a normal, or not, in like a non-urbanized area, rain will fall and will get into the groundwater wherever it is that it's falling. So we'll either create small little tributaries in like depression areas that lead to bigger streams, or they will be absorbed by the plants in the soil where it falls. What we have happen in urban areas is that they're falling onto pavement, falling onto rooftops. So they're hitting areas that are not going to let it drain into the river, drain into the ground to go to the river. And instead it will go into, like, say, drain pipes. So our tributaries that normally would be allowing water to soak into the ground and provide habitat for other animals now become just like tunnelized pipes that push all the water quickly to a river. What happens is you have all that extra pressure and volume hitting the river really, really quickly. So it's not that the river gets more water than it used to necessarily, but it does get it a lot quicker. And so all of that extra pressure pushes against the side of the river and can cause erosion. And you can lose bits of the edge of the land falling into the water. And we'll kind of talk about why that's an issue later, as opposed to just the obvious of you're losing the banks. So water infiltration. So bank stabilization. So not only is it helping with the water coming into the river, but just literally those trees and the vegetation right up against the side of the river, those root systems are holding soil in place as well. And then we have the habitat aspect. So if you can kind of see the tree that's behind this black square here, these are huge root systems of one of the sycamores. And what you'll end up having happen, especially, I don't know if any of y'all are fishers, but those will create these big, like, undercut banks and pooled areas next to these trees on the river. And so those deep areas end up becoming nice habitat for some of the bigger fish. they can get under that root wad and get protected from predators. And then you also have the actual small like tendril roots that end up into the edge of the water where animals can live. Some of the macro-invertebrates, it's a nice shelter place for the smaller fish. So that aspect of habitat, but then also the leaves that fall into the river and form like leaf packs up against rocks. Some people might look at that and say, oh, you know, it's dirty, there's stuff in the water, let's get it out. But that, as long as, or in addition to like big pieces of wood, tree limbs that fall down, that all creates habitat. It makes the water flow a little bit different. You can have a break, like it's stopping some of the water flow so that fish can hang out there in the slower water and kind of catch a break. And then also protecting them from larger fish and herons and things. And then some of our macro-invertebrates that we're going to talk about later eat the decaying plant material too. So it's a little bit of base of the food chain there. All right, so the third thing that we look at when determining whether an area should be a scenic river or not is the biodiversity. So that is our macro-invertebrates, but it's also going to be our fish. So we look for lots of different types of these animals. What would that say like for the terrestrial system if you have a lot of animals in the river? Like this is all connected. So the birds, the herons, the eagles, you know, they are eating the fish, which have fed on either the algae in the river or the macro-invertebrates in the river. There are studies that look at the carbon molecules of the carbon atoms in these animals, and that they end up hundreds of feet away from the river. They look at the isotopes. So animals in the stream, their energy is going out into the terrestrial world. So it's really important to have that healthy base system here in the stream to support the terrestrial ecosystems as well. So I was mentioning macro-invertebrates. I should have done this earlier, describe what that word means. So if we break that apart, macro just means big. So here we have a macro-invertebrate in my intern's hand here. So it is large. It's something that you can see without magnification. And it's invertebrate, so it does not have a backbone. So we are not looking at fish. We aren't looking at salamanders. We're looking at insects. We're looking at crustaceans, mollusks. And so those animals we're going to go into some greater detail here at the end. But why are we looking at them? It's kind of the question. So what are they telling us? So our macro-invertebrates, many of them are sensitive. So they're sensitive to pollutants in the river. And they're also rather long-lived. So they can live a couple years. Some of them live 3 or 4 years in the river as this juvenile stage before they emerge as a winged insect. And so because they have to have that long life cycle in the river, that system, if they're one of these sensitive critters, they need that system to be healthy and intact for that long of time. So if we're consistently finding them in the river, that's telling us that that system is still healthy and isn't having a lot of issues. So chemicals, oxygen, heat. And so a lot of these things are, impacted by whether or not you have that tree system or prairie system on the edge of the river. And then sediment. So I was talking about erosion earlier. Why do you think sediment is going to be an issue? And erosion happening along the edge of the river, putting dirt into the river. So if you see this picture, you see all of these spaces here around the rocks. And these critters are not going to be hanging out on the top of the rock here because this fish can easily pick them off. So most of the habitat for these macro-invertebrates is in the crevices around these rocks and underneath these rocks in the gaps. So in those spaced areas, if we have a lot of soil and sediment getting into the river, it starts to fill in all of those gaps and then closes off those habitat areas. It can suffocate their gills. For the fish end aspect of this, you have visual predators. So too much floating debris in the river can make it hard for them to see. It can also irritate their gills. So that is one of the big issues, that if we have a lot of sediment in the river, we aren't going to see a high volume of macroinvertebrate communities. So in terms of how we determine if it's a high volume or low volume, we're going to kind of look into how we would measure these macroinvertebrates. So if you would come to one of these spring or summer workshop programs, this is what we would do, like physically at the river, to tell how clean or dirty the water is and how healthy it is. So we use what's called a kick seine. So you can see it's got net about like 3 foot by 3 foot with 2 poles. What we would do is go out into the river, and you can see these participants over here are kind of shuffling. They're moving their feet in the river. Let's see here. And it's kicking these animals up from the bottom of the rocks and putting them into the water column so that they can flow into the net. And then we would take that net over here to the shoreline and start to identify them. So we chose this method because it's cheap. It's something easy that a volunteer group can get involved with, or like Paradise Nature Center would be able to get involved with, because it's not going to have a lot of like background that you need to get into. You can get this off the ground pretty quickly. The identification is pretty simple once you learn it, and we're going to kind of go through some of those steps at the end here. And then it helps us to just see if we're finding our sensitive animals or not in a very quick manner. So it's kind of like the canary in the coal mine. So if you just do a sample that doesn't take a lot of time and you find sensitive animals, you can know, well, okay, I don't know exactly everything going on in the river right now, but I know at least it's keeping these sensitive animals alive. Now, if there was an issue where you were not finding sensitive animals, you could go into a deeper, more in-depth way of monitoring the river, looking at chemicals and things like that. But all of that takes more time and it's more expensive. So this is that nice, cheap, easy way to figure out if things are okay or not okay, and figure out if you need another step or not. So as where we do the sampling, you see the water down here? It's kind of choppy at the top. There's some disturbance. So but we call that the riffle. So the top of the water is riffling. Does anyone know why we would want to be in an area where the water is chopping? Do you know what that does to the water chemistry?
Adds oxygen.
It does add oxygen. So that just increases the surface area. So it's helping to mix the oxygen in the atmosphere down into the river. And like I said, one of those things about the sensitive animals is that usually they need higher levels of oxygen. So if your sole purpose is to do a quick, easy, cheap sample somewhere, you're going to go look in the riffle. So you don't have to go searching throughout lots of different areas of the river. If you do not find sensitive animals in the riffle, they probably aren't in other areas of the river. So this is kind of a little brief overview of what our identification sheet looks like and how we would score the river. So we've broken these animals up into 3 different groups, and I'm going to go through the identification of these right after this, but just to see how it's broken down. We have 1, 2, and 3. And in these sensitive groups, if you find one of these animals, we give the score of 3, just if you find that type of animal. So if you find here, CADDISFLY, you get 3 points. And it doesn't matter how many of them you find. If that is present, you get 3 points. So you would do that for each of those animals up in that sensitive group. And we have 7 different sensitive animals up here. So if you found all 7 of those, you would have 21 points. But our index over here is showing that if you want an excellent score, you need to have more than 22. So if you would find all of these animals, you would only end up with 21 points and you wouldn't have an excellent score. So our index is sort of structured in a way that it's wanting to make sure that we're finding animals in all of our groups. So these somewhat sensitive to pollutants, if you find any of those, you would get 2 points per group of those animals. And our very tolerant ones, you would get 1 point. And so we're trying to find this biodiversity of the food chain here within the river, because these animals in the very tolerant, they're not bad. They just have different adaptations that allow them to live in areas that maybe are a little bit more pollutant, or if they have maybe lower oxygen areas of the river. But they're still being present in the river is a good thing. Some of them are detritivores. They're breaking down things in the river. So you don't want to have, tons of leaf matter hanging around all the time. You want something to be breaking those down and making them in smaller particles for other animals to eat. And some of these are also just food for some of our predators, like our stoneflies might be eating some of the midges. So biodiversity is key. This is normally my closing slide on other webinars. We're just going to pass this one because we're going to go into the identification. It's just our food chain. Okay, does anybody have any questions before I move on to this section?
Yeah, Christine, so documents like, if somebody were interested in pulling up some macro-invertebrates and they wanted to kind of score their stream, documents like the pollutant sensitivity chart that you just showed, are those available anywhere for people to find?
I can email them out to anybody.
Okay.
Yep.
Yeah.
Yeah, because you can do this in your backyard stream. It doesn't have to be part of a program. As long as you have permission to be on the land, you are allowed to go out and do this. You don't need permits just to sample a river and put the animals back. So the key is just to make sure that you are not collecting the animals and that you're returning them to the stream afterwards.
Excellent.
Okay, so let's look at some of these animals a little closer. So this is the first time that I've been going to try teaching macroinvertebrates on a computer. So please let me know if you have any questions or if something's not clear, because normally we're out in the stream and we're holding these animals and we're seeing how they move. We're seeing how big they are compared to each other, things like that. So I tried to break down those cues as well as I could on the computer here. So just let me know if something's not clear. So I figured we'll kind of look at 3 different things for most of these animals. So it's 3 B's. We're going to talk about what their behavior is, talk about how they breathe, and what the back end of them look like, whether they have tails, whether they have gills. So these are the 3 different things that we usually use to teach macroinvertebrate identification in the field, because sometimes you're just comparing and contrasting these animals against each other, looking at these things. So we'll start here with caddisfly. So for most of these animals, I have put up in the left part of the screen what the adult looks like, because as I said, most of these animals spend a couple of years as a juvenile form, a larva in the river before emerging as an adult. And those adult life forms, they might only last a few days. So most of their life cycle is in the river. So some people may not even know what the adults look like if they're not paying attention. So these are our caddisflies. And for behavior, I put them as a slow crawler. So if they're on your net, they're not going to be moving away very quickly. We also make sure that our volunteers put the animals into water. So all the volunteers receive a bin where they can take the animal from the net and put them into the water, because some of this behavior and some of the body structures are hard to see when they're just sitting on a net. So if you would put that into the water, you would see that this caddisfly, they do not swim. So they might crawl around a little bit, but otherwise they're pretty stationary. In the river, they will make structures like this. If you can see, these are teeny little pieces of sediment. And this caddisfly has actually glued those together. So they have silk glands near their mouth. And if you look at this adult form, again, you can see they kind of look similar to a moth or a butterfly. And if you think of those animals, they also have the silk capacity to make their cocoons and chrysalis. So they are similar. So these guys will glue structures together, or like down here, they will make silk netting in the stream as a retreat. And that will help them collect and filter feed little pieces of carbon. So this could be like algae and things that are floating in the river that get caught on this silk, and then they can eat it off of the silk. For breathing, most of them are breathing through the skin, but there are some like this, which is our common net spinner, which will have gill, like kind of like feathery looking gills on their abdomen. When they aren't in preserving solution, usually they'll look green. So this is an animal that you'll see pretty much at every, at least all of our scenic river sampling sites. You'll find these animals a lot. So they're usually, I'd say, one of the first things that people learn to identify, because they see them all the time. And then for the back end of them, if you see this picture here, a little close up on the back end here, you see they have two little claws. So when they're on your net, sometimes they're hard to pick off because they have those claws into the netting. And then also for movement, sometimes they will back up. They'll put those claws in the net and they'll kind of scooch backwards that way for movement. So those are some of the identification aspects of them. They also have a harder exoskeleton, and this will vary on what type of caddisfly you're looking at, but it'll be on the head for sure, and then some of the areas where the legs are. But their abdomen, where there are no legs, will always be soft. And then I have some pictures too of some other structures for these caddisflies, because they do, and this doesn't even show you everything, but they have lots of variety in how they will make their cases. Some of them will be very cylindrical, and then some of them will have things like small pieces here in the middle and bigger pieces on the edges. And so these caddisflies, they're all making these. So they're all making those decisions to pick up what size stone to put onto their case. It's pretty fascinating. When one's up here, and these are snail case caddisflies, they'll glue the sediment in like a curlicue, like a snail shell, and they'll be inside that, like wrapped up. All right, so here's our stonefly. Here's our adult up here. Now, as opposed to the caddisfly that's doing a lot of filter and gathering, a lot of the stoneflies that we find are predators. So this is our common stonefly here. And then this one up here is our giant stonefly. We'll find these up on Mohican and Cocosnic a lot. And these ones are one of those detritivores. So it's eating detritus, it's eating the decaying like leaf matter and plant material and other material in the river. So it's helping to break those things down. So our stoneflies, these are the ones that we warn you will run off your net pretty quickly. So that helps a bit with your identification. You got to catch them before they get off your net. If you do pick them up and put them in your water bin, sometimes you'll see them doing push-ups. And unfortunately, I can't share a video. I didn't want to crash my computer with this. But they'll do push-ups to circulate oxygen around their gills. So their gills will be usually little like hair-like, and they're not super obvious, at least on the common stoneflies. And usually by their legs, the giant stonefly does have some bigger, more obvious gills, but again, they're usually up by their legs or the very, very top of the abdomen. So again, the abdomen is pretty clear of gills. And then for their back end, you can see all these have 2 long tails. So there's no hooks. They're just two long tails. So mayflies. I think pretty much everybody would recognize what an adult mayfly looks like. And also that they tend to get kind of a bad rap. Like when the mayflies emerge, they emerge everywhere, right? And they get on everything. But if you noticed from that previous identification sheet, they're up in that top group. So they're in our sensitive group. So it's actually a pretty good sign if you're having a lot of mayflies emerge in your area of town. So most of our mayflies are swimmers. So if they're on the net, they might actually kind of flip around like a fish, because it's just how their body functions. They don't generally crawl on the net unless it's one of our like flathead mayflies, which actually, if you see down here, their body's flattened and they actually are more of a clinger than a swimmer. So they might crawl on your net very slowly. For breathing, you see all of these appendages on the abdomen here. Those are the gills. So unlike the stonefly, which you would not see gills on the abdomen, you do see them very prominently on mayflies. And if you put them in water, you'll usually see them kind of furling and moving actively too. So it's pretty and it helps you identify them. And then on their back, they will have 2 or 3 tails. So normally 3. However, they are a lot more slender and fine than the stonefly ones. So they can break too. So sometimes they end up looking like they only have 2 tails. So it's really important to look at those other factors as well, the swimming and those gills on the abdomen, so that you don't immediately see 2 tails and assume it's a stonefly, because there are some differences there. Any questions?
I mentioned 1 claw too on the mayflies.
Yeah, I was trying to figure out how, how in depth to go. But yes, and I might have actually said on the, I don't know how to back up, on the stonefly one that they have, yeah. So I mentioned it on the stonefly. So the stoneflies have two claws and the mayflies have 1. Thank you, John. Okay, so this critter, it's called the DOBSONFLY, sometimes the HELLGRAMMITE for the larva. If there are, again, any fisher people here, apparently these are really good bait. They're so big and fleshy. So this was one that I really wanted to make sure that I had hands in my pictures, just show you how big they are. So this is the adult, or the adult male. The females look a little different. And then these are the larvae. And these are also in our sensitive group. And they start out when they hatch pretty small, like 3/4 of an inch. And they get to be, that big, chunky guys. It takes them a few years to get to that size, to when they would crawl out of the river to pupate and then become an adult for a few days or a couple of weeks, depending on male or female. So they spend a ton of time in the river as this sensitive organism. So when you find not just HELLGRAMMITES in general, but the real big ones, then you know that they have been in that river system for a few years. And that's a pretty good sign for the river there. So you see those huge mandibles too. They are predators. So I've actually caught them before when they are actively eating another animal. So they're pretty impressive, but be aware that yes, they can pinch you with those pinchers, but if you hold them like this picture over here, just right behind the head, and then just place them on your hand, that's not a threatening movement for them. You're just another piece of rock or something that they're crawling on. It's the poking and stuff at them that will cause them to turn around and try to bite you. So be aware. I have not been bitten by them. I think they're pretty cool. So other behaviors, if you would put them into their water container, they can undulate that body and use that kind of back tail to swim backwards. And they will crawl off your net too. Not as quickly as the stoneflies, but they can walk around. If you turn them upside down, this is kind of the best picture I got. So it's not the best, but if you see these little dots here, these are all gills. So on each of these abdomen segments, so where these legs are, that's one segment, and then this leg, that's another segment. On each segment, it has pairs of gills, big fluffy, puffy gills. And then on the back here, you can see those two. So it's at their tails, but they have hooks on them, like the caddisfly. But these are a lot stronger hooks. They actually, for these older larvae, they feel like Velcro. You can feel that resistance on your hand if you touch those tail hooks. And that's really helpful for them being in the fast riffle. So they can hold on while they're walking around and actively looking for their next meal.
Hey, Christine, this is Joe Carter. I have a question.
Hi, yes.
On the HELLGRAMMITEs, when they're smaller, how similar, like, you know, say a 6-month-old one or something, how similar do they look to the bigger ones? They look similar enough to me. They're just smaller. I think usually those small ones, the easiest thing to get confused with is some people might think like one of those small caddisflies are a small HELLGRAMMITE and vice versa. But otherwise, like if you put them in water so that all of those, you know, the side filaments can kind of flesh out, you'll see all the body structures. So they still have, you know, the sclerotized head, that exoskeleton right here, and they're still going to have each of these little side filaments. They're just smaller. Okay. So for these small critters, we do give all the volunteers little magnifying boxes. It's like a 3x magnifier. So sometimes putting the smaller animals in there will help with some water to be able to see those smaller structures when they're young. But otherwise, they would have all those structures still. Okay.
So this is another one of our sensitives, our RIFFLE beetle. So we look for these animals both in the adult form and in the larva form. And this picture is deceiving because that is about how big they are. Depending on your screen. I tried as best I could. They are small little beetles. So they will sometimes be, I feel like, one of the last things that you notice when you're doing a sample, because you're seeing these bigger animals flop around or walk around. And then it's kind of toward the end where you start noticing, oh, there's that little black dot that's moving across my net. So those would be our RIFFLE beetles. There are other beetles that will live near the river, but these are the ones that will spend almost the entire life underwater. So when they become an adult, they'll emerge from the river and they will fly, and then they immediately come back into the river and those wings atrophy, they don't use them anymore, and they live their whole life in the river. So the fact that they don't come back up afterwards means that they need to be in an area that has high oxygen levels, because other beetles will take oxygen from the air, kind of dive down with it, do their thing, and come back up, and they'll do that. The diving beetles, water penny adult beetles. So they're one of our sensitive indicators because of that requirement to have high oxygen in the river at all times.
So kind of just talked about that. And so they don't have any tails or anything like that. As the adult form, they just look like a tiny little black beetle. But here is our larva beetle. And so their backside, they do have some tuffy gills. Sometimes we'll call them a cotton butt. So they'll have these like white tufts that come out, and then they'll bring them back into their abdomen and put them back out. Sometimes these guys, you know how big the adult is, the riffle beetle larva is also very small. And they will get confused with caddisfly because they kind of have a similar body shape. They have the 3 pairs of legs. So a distinguishing way for them, I tell the volunteers, is to look at or pick them up and feel them, because the riffle beetle larva has this hard exoskeleton, whoops, sorry, all the way down their body. Whereas that caddisfly only had that hard exoskeleton up at the front, and then they had a soft abdomen. So that's one way you can tell the difference between the two. And then the other is that the caddisfly will always have those tail hooks out. It can't retract. So even if these gills look like tail hooks without magnification, then you can watch them in water and see if they pull them back in and put them back out, put them back in. So that'll help you distinguish those two. So I mentioned the water penny beetle. So this is the adult, and it's one that we do not look for in our survey, because once it is an adult, it will be only semi-aquatic and using the oxygen from the air. But we do look for the larva. So these guys look sort of like, I don't know, like a trilobite, I think. They are very flat. So this is showing you kind of the wrong way, but if you were looking at just a rock, they would just be this teeny little blip, like it says their name, water penny. So they're just these flat little coppery animals on rock surfaces. So they will kind of scoot along really slowly and graze on the algae. Sometimes people think these don't look like insects. So if you're looking on the underside of them, or put them in that magnifying box and have them upside down, you will see that they have a head, that they have 3 pairs of legs, and they have the gills. So they are little insect larvae there. And no real back appendages. They, like I said, just kind of look like a flat little coppery penny on a rock surface or log surface. Okay, so here's some dragonflies. I think dragonflies and damselflies are kind of the surprise for a lot of people, that they don't realize that these animals live as larvae in water systems. So pretty much everybody knows what an adult dragonfly looks like. So here are some examples of our larvae. So some fun things about them. The way that they move in water is that they will have jet propulsion. They will suck water up through their abdomen and just shoot it back out. So when you put them into your bin of water, you'll see them kind of go whoop, 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 as they bring water in and shoot it back out, kind of in this halting motion. And then if you see here, their lower jaw looks kind of like a flat panel under their head. So it's actually kind of hinged back in there. And this picture shows that jaw being used. So it's actually eating a fish, these dragonflies. So these, they're like ambush predators, and they will wait for a snack and then release that lower jaw, which will have some kind of hooks at the end of it to capture what they're trying to eat, and it pulls it back in. Pretty fascinating. And just so you know, the dragons, the adults, they are also eating a lot of other animals. So they are one of our big mosquito eaters. So like, I forget the numbers, but if anybody knows, shout it out. But it is a lot of mosquitoes in a season for a dragonfly. The other thing is, you'll notice on their back end, not the back end, but their back, you'll see as they get older, they'll have wing pads. So that's right here and right here. And so you can kind of estimate about the age of a dragonfly based on whether or not you can see its wing pads, because it doesn't get them until it's molted several times. So the dragons can spend 2 years in a river too before they emerge as an adult. And so you can kind of guesstimate your age based on if you see the wing pads and how big they are. So for breathing, just like when they're doing that jet propulsion, those gills are also internal. So they're bringing water in to breathe and letting it back out. And no real tails. They kind of have these little, like, I don't even know what you would call them, but little edges on their back. But they,
points.
What?
5 points sticking out back there.
5 points?
There's 5 of them total.
But so they're like kind of like teeny little spikes versus those like long tails that you would see on stoneflies or mayflies. Okay, and then damselfly. So these ones are similar to dragonflies, but they're a little bit more slender. And they also usually will keep their wings to the back of their bodies when they are resting. And so these ones, just like dragons, are really good at climbing and crawling. They're also predators. So here's another one doing that lower jaw release to grab a midge. The difference here for their body structure is that they do have external gills. They can also breathe through their skin. So if they lose one of these or a couple, like they'll still be fine. But you can see that that's a lot different than what those little spikes on the back of a dragonfly are. So they're big, they kind of look like paddles. And they can also use that to swim, kind of use them as fins. And this one over here, you can see those wing pads too. Okay, so some other animals that are not insects, we have our mollusks. So we have 2 different types of snails that we look for. We have our left opening, which we call our pouch snails, and our right opening, which we call our gilled snails. So these ones just scrape off algae off of rocks, just like those water penny larvae. And the reason that we put these guys into that sensitive group is because they do have internal gills where they're using to use the oxygen in the river. Whereas these pouch snails, also called lung snails, can emerge from the river, take in atmospheric oxygen, and store that inside and be in parts of the river that do not have high oxygen. So both of them will be in a healthy river system, just in different parts. So the pouch ones might be more along the edges where the water's slow and more pooled, and therefore it's not getting all that chopping and oxygen being dissolved into the river. If you think about it, the pouch snail has an adaptation that allows it to be in other parts of the river to continue grazing algae instead of being in a riffle where it's going to be competing against the gilled snails and the water pennies and the flathead mayflies that are all eating the algae. Then we also have clams and mussels. These are filter feeders. They use a siphon to kind of bring in water, and that will bring in food as well. And so they bring in this water, they'll get in oxygen, they'll get some food, and then they'll excrete it all out the other side. And in terms of visuals, the mussels are asymmetric, whereas clams are symmetric. And also good thing to note is that the mussels, their shells and clam shells, these are all protected in the state of Ohio because we used to have an issue with mussel harvesting. And so if anybody is familiar with the Big Darby Creek, it is one of our scenic rivers and has a very high mussel population, like over 40 different types of mussels. And that is a huge biodiversity just like, I don't know, call to fame. Like there's no other place in the United States that has that many mussels in a river system. So it's pretty special. And so because of that, those shells are protected. So if you ever going to the river and hanging out and finding those and looking and seeing how pretty they are, make sure you do put them back into the river system. So some of our other critters, some crustaceans. So most of these are scavengers. They'll eat whatever they can get to, whether that's, you know, decaying things, plant material, animal material. We have scuds, which are freshwater shrimp, and we also call them side swimmers. So this animal and our sow bug, they have a lot of legs, and they have that kind of hardened crustacean exoskeleton. So they look similar, but if you would get these both in your sample net, put the animals in water, and that side swimmer, the scud, will be oriented on its side and swimming. Whereas the sow bug will just kind of crawl around and walk. These ones look very similar to roly-polies, potato bugs. They have lots of different names. And then crayfish, pretty sure almost everybody knows what a crayfish looks like. So they can also pinch you, especially the bigger ones. So similar to the dobsonfly, it's always pick them up right behind their head. You can kind of pinch them right behind the arms, and so you can push those claws forward, and then they cannot get you. Then one of our last slides here are the different types of flies that you can find in the river. So these are also insects, but these larvae will never have jointed legs. So that's one of our ways to distinguish them from some of our other animals. So this one over here is a crane fly. And I bet most people have seen the adult crane flies before. They can be kind of big depending on which one you're looking at. So they look like giant mosquitoes, but they are completely harmless. So if you do see them flying around, don't worry. The larvae also are harmless, though you might feel them sort of nibbling on you like a mealworm, but they can't actually bite you. So for the crane flies, they will have some sort of appendage at the back. Some of them have just like kind of a couple tails. Some of them have almost looks like an octopus, like just lots of appendages on the back. And they can also flatten their body to swim in the water. So again, pick these animals up off the net and put them in some water to see what they do. But none of the flies will have a hard exoskeleton. So they will all have soft bodies and no jointed legs. Our midges will be smaller than the crane flies, but you will be able to see a head. So if you put them in those little magnifying boxes, you would see a head, because they really are small, like just like half the tip of my fingernail, like very small animals. But they will have little nubs on their body, which are called prolegs. They help with movement. And a lot of times too, they'll be very like spastic on the net, just like kind of flipping around. We usually will find them on little pooled puddles, like just little water droplets on the net. And if you look in those water droplets, you'll see midges kind of flailing around. And then the black fly is also going to be a really small larva. You can see just on the tip of a finger here. But as opposed to the midge, which is all kind of pretty much the same width and very cylindrical, the black fly will have a smaller head, and then the backside will be much larger. And if you put that in water, usually it will attach with that big bulbous side, and will just kind of like flail in the water. They normally would be filter feeding like through their mouth up there and just flowing like some algae. And then our worms.
Christine?
Yeah.
To dispel a rumor on the adult crane flies, they do not eat mosquitoes. They don't have a mouth.
Right.
Adult crane flies do not eat.
Yeah. So not only can they not bite, they are not eating. Good point. but they do make wonderful food for some bats and birds. I'm sure huge emergencies of crane fly are smorgasbords for some of our other animals. So I think this is our last one, just going over a couple of the worms. So all of the worms are in that last category, the one-pointers. So we have just kind of a catch-all of just aquatic worm. So these will look very similar to ones that you'll find in the yard, terrestrial worms. They're slow-moving, they don't swim. A lot of times they're the hard ones to get off your net later because they will just sort of thread themselves through the net. But you don't see any distinguishing like features on them. There's no prolegs, there's no mouth part that you can see just from being on your net. And then we have leeches. So they are also a type of worm. But these ones, they feel a little more muscular. And if you flip them upside down, there is a sucker on the one side and a sucker on the other side. And you can actually see that. And also if you put them in the water, they can flatten themselves out kind of like a crane fly and undulate and swim through the water from one side to the other. It's pretty cool. They also can use those suckers to inchworm themselves. So they can suck down on the one side, lift up, and suck down and pull themselves forward. So that's another way they'll move across your net. But just to also, speaking of dispelling rumors, most of the leeches, especially the ones that you find in that riffle area, are engulfing predators. So they are there to eat some of the other smaller animals. And they actually do not feed on humans. So that hopefully will make you feel better. I've never been bitten by a leech either. And then we have our flatworms. And these poor guys sometimes will get confused with the leeches because people see us something small and gray and smushy, and it's kind of sticking to them just because it is kind of slick and slimy, and they'll think, oh, a leech is attached to me. So make sure you kind of look at the rest of what this animal is doing. If you put it down into the water and let it start moving, you'll see that it has 2 eye spots, whereas you do not see any eyes on a leech. And then they also do not swim, but they will, I think one of the features that confuse them with leeches, aside from just being sticky, is that they will also pick their head up and kind of move around when they're on your net. I think that's probably a response to just being out of water and wondering, oh, what's going on? How do I get back into the river? But they do not swim. And they also are smushy and not muscular like a leech. So I think that's the end of what I have here. Just another fun picture that I wanted to throw in. You saw how small those riffle beetles were. This is a picture of a micro-caddisfly next to our riffle beetle. So remember, those riffle beetles were about the size of what my cursor is. So that's a pretty small animal. Anyway, do we have any other questions? Feel free. I'll try my best to answer them.
Yeah, if anybody has any questions, feel free to unmute here on the Zoom call, and I'm going to go check in on Facebook for any questions. But first, Christine, I wanted to say thank you. That was awesome. That was like the perfect slideshow.
Good.
Yeah, and go ahead.
I'm going to keep tweaking it.
Yeah.
This is my first time doing macros on a computer, so yeah, I welcome any feedback.
Oh yeah, no, I really appreciate the adult stage on each of the slides.
Right.
That's very helpful. Yeah.
Oh, and also with those pictures, I do want to say that some of those were DNR photos, but I did use macro-invertebrates.org and lifeinfreshwater.net. So please check out those websites if you want to see any other really great bug pictures. So.
Yeah, that sounds awesome. Hey, I had a question about the water penny.
Yeah.
So when its body is flat up against a stone, is it keeping itself there through like suction action, or is there just latching going on?
I don't know the actual science behind this. I would have to kind of look it up, but I feel like it's losing, or just like there's no friction, you know, like it's so flat against that surface. I mean, it is holding on, and you can feel it holding on to you when you pick it up, but it's not the same as like the claws of the HELLGRAMMITE, where it feels, I mean, it literally feels like Velcro. It feels really strong. So I don't feel that myself with the water penny. So I feel like it's just more of an issue of, it just is so flat that the water just is going over it. But I can look in and see if I can find a better explanation than that, and we throw it on Facebook afterwards.
Yeah, I was also going to say thank you. Great presentation, and the advantage with the computer is that you can magnify them and they don't wiggle around. I mean, you don't see the behaviors that way, but you can see the structures much better. So
yeah,
thanks,
Petra. I was hoping, like, I wanted to find pictures that would look more like what you would see in the water than ones that we see when we preserve the animals, you know, like, I was like, what are they looking at when you're doing a sample? But good, I'm glad you liked it.
Awesome. Hey, Stephanie here on Facebook, she just wants to clarify that these macro-invertebrates, when they emerge, that's mainly for breeding.
Yeah.
Yeah.
Correct.
Excellent. And if somebody was interested in doing some chemical sampling, do you have a suggestion on where to get the kits, or can they use, you know, the kit they bought for their pool? I mean, what are your recommendations?
I don't know about the pool kit. I know that there used to be a program through the Sierra Club called Water Sentinels, and they would do that. So whether or not they still do that, I don't know, but you could certainly call or email them, the Sierra Club. Okay. I'm sure they would be able to direct you to the someplace.
Yeah,
if they don't do it.
Oh, Anne is asking, can we get more magnifying boxes?
Yes, just email me.
Very good. Are there any other questions? Fantastic. Hey, if we wanted to get involved, or if somebody wanted to get a little more involved and get some training, what does the timeline look for that?
So normally we would start our sample season May 1st. So sample season normally would be May 1st through October 31st. Like I said, this last season, we didn't do any of that. Well, we didn't do any new trainings. We certainly had our volunteers go out. So hopefully we'll have to kind of see how it goes. But I would hope to be doing group trainings, even if they're just smaller group trainings with masks in May. And if not, then maybe later in the summer. So I think the best thing would be, if anybody is interested in that, is to email me. And I could throw maybe I should put that back up in case people still need that. But you can email me. And I have a list kind of growing of people that are interested in our volunteer program for future. And I'll keep you all informed on what our timetable looks like for that. But generally what we would do is do a workshop that covers similar topics, but out in the field. And this would normally be at a metro park. So the Darby Metro Park, or up at High Banks. And then after that, I would show you what sites are available. So we have 15 rivers in Ohio, but the ones that I work on are the Olentangy, the Darby, the Kokosing, and Mohican. So I have 39 sites between all of those rivers, and a handful of them still need some volunteer coverage. So I would share those with the prospective volunteer, and then they would choose their river site, and then we would pick a day, and I would go out with just them, or there's maybe a team, 2 people if they want to do a group, and we would train at their site. So I would show you exactly how to access that site, and where the riffle is at that site, and we would go through all the methods again at the river so that you can feel comfortable with it, especially with the identification.
Great. Great. And so once everybody goes through their training and they start making observations, they're at their site, and they're collecting data. So what would they do with that data after it's collected?
Yep, so they would just email me back. So I showed you the picture of the animals that we look for, but there's another sheet that kind of has check boxes and sort of tally mark things. And so that's an electronic sheet that I email out to the volunteers too. So they can just type it back into that, email it back to me as soon as they can after they do their sample, because we are trying to get 3 samples during the sampling period from May 1st to October 31st. So a timely return of that data is helpful to make sure that I can see where we're getting samples and which sites still need to get sampled. And then also in terms of the sampling, we do provide you with the gear. So we give you the net, a shower curtain to put the net on and to catch any of the animals that fall through, the bin and the magnifying boxes. So we set you up.
Yeah, that's so you're like a compiler for that information too.
Yeah. So we have all that information in a database that goes back to like 1983 or something. So we've been doing this for a long time, especially on some of the rivers. Olentangy, I think, was 1973. There's a lot of data for some of these river sites. And we have it on our own database, but we also give it to the Ohio EPA as part of the credible database. So all of that information is public if anyone ever wants to dig around.
Awesome. Are there any other questions? If not, perfect. This was awesome, Christine. Thank you so much. Thank you everybody that joined us this evening. And at this point, you know how to get a hold of Christine. And if you're interested in what Paradise is doing, you can get a hold of us as well. Let's see. I think Anne had one more question about attachments for an Android phone that takes magnified photos. Do you have any direction there, Christine?
No, but I feel like John Lorenz might. Well, if she emails me,
Google magnifier for Android. See what pops up. I have a free one from my iPhone, and I could pay for it and get a little more enhancement. Keep in mind that those things are always magnified 100%, and they just steal pixels. So if you take the picture, blow up the picture, you get the same thing, in theory.
That makes sense. Yeah. Huh. Very neat. Awesome.
Well, thanks, Tyler, for having me as a guest.
Yeah. Thank you, Christine. And yeah, hopefully we'll get you out here this summer, or this upcoming summer. And yeah, we'll get some trainings going. So I'm excited. All right.
Sounds good.
Hey, I appreciate it. And I'll shoot you an email here right after this.
All right. Sounds good.
All right.
Thanks, everybody.
Thanks, everybody.